All the Form 4 students, today I would like to carry out the inquiry number 3. You open the textbook page 20. Okay, page 20, inquiry number 3. Now, the aim of this inquiry is to explore the relation between the graph of a function and its respective inverse. So now, please scan the QR code or visit the link on the right on the page 20 textbook KSSM Additional Max. So have you scanned the QR code? Okay, after you scan the QR code, you will see something like this. Chapter 1, Inquiry 3, right? So you'll be given a few functions. Okay, you have to click on the button of the function. Okay, let's say the first one is hx equal to x. You can click on the box, okay, or we call it button, and study the graph obtained. So hx equal to x is a straight line passes through the origin, okay, of the x and y axis on a Cartesian plane. So now I'm going to click another one, which is let me zoom, which is f1x equal to 3x. So let's have a look. You can see the red line. That is the graph f1x equal to 3x. We can call as function f1x. So it's actually passes through origin also. Alright, now I'm going to click another one, the function just on the right to the red line just now. Now this is another function, fx equal to x over 3, right? So you can see that these two functions, the red one and the blue one, actually they are symmetrical about the line hx equal to x, right? So meaning that these two actually the graph of these two are actually inverse. Okay, the graph are inverse to one of them is function, the other one is the inverse. Okay, let's try another one. So the function f1x and the fx actually they are inverse, and then we try g2. So I take out this one. Okay, I take out this one. So you can have a look of g1x, which is 2x, is in purple color and is actually symmetrical, right? How about this one? Okay, they also symmetrical, right? It seems like 2 over x and the inverse also 2 over x, right? So then I take out these two. I try another one. This is p1x equal to 3x plus 5 is in red color. Then the inverse is px equal to x minus 5 over 3. As you can see, the graph actually all the graph actually they are symmetrical on the line hx equal to x. So the question asks, are the graphs of each function as is inverse symmetrical about the hx equal to x? So as you can see, the graph and the inverse are symmetrical at the line hx equal to x, which is in green color. Alright, okay, so this activity is very meaningful, and you can understand how the relation between the function and the inverse, they are actually symmetrical about the hx equal to x. Alright, okay, so I'm going to show you again. Okay, so you have the hx equal to x, right? Now if the graph of each function and its inverse are symmetrical at the hx equal to x, then which is actually hx equal to x is actually y equal to x. so they are symmetrical, then that should be the inverse. Okay, so let's have a look of this one. So you can see this one is red color, this is blue color, right? And this one I'm going to show you another pair, this one and this one. Okay, I'm going to show you this one and this one. Hello to all the Form 4 students. Today I will actually do the inquiry tree with you. So for the video that I discussed just now, we actually discussed about the relation, okay, between the graph of a function and its respective inverse. So actually this is very important, and the concept is from the result of inquiry tree, we found that every graph of the function and its graph of inverse function is symmetrical about hx equal to x, that is y equal to x. So the graph f negative 1 is the reflection of the graph f in the line y equal to x. Alright, so reflection, remember. So I also teach you the concept of the fx equal to y and f inverse equal to y will maps to x. So when y equal to fx, x equal to f and negative 1 y. So when you found the x, meaning that you found the inverse. Okay, so we have discussed all this. So then this one, we are going to do another inquiry 4. For inquiry 4, okay, let's see the inquiry 4. Now you need to actually go through all the inquiry on your own. You can have a better understanding. So for this inquiry, we are going to make and verify the conjecture. Okay, we're going to verify the conjecture that one-to-one function has an inverse function. Okay, only one-to-one function has inverse function. Now you have to copy and complete the mapping of the following discrete function. Discrete function g. Okay, let's do together. Okay, you have to copy down this one in your exercise book. Okay, let's see. Because x is go to x squared, that means 1 will go to negative 1 will go to 1, negative 2 square will go to 4, 1 square will go to 1, 2 square will go to 4, right? Okay, so this is inverse and inverse of g. So if you inverse back, 1 will have 2 images and 4 will have 2 also. 1 will have 2 images and 4 will have 2 images. So this is one-to-one relation. This is one-to-many relation, right? So as I mentioned just now, one-to-one relation has inverse, right? So that means we'll answer the question after this. Okay, let's see. This one is h will bring the x to x plus 2, negative 2 plus 2 will be 0, 0 plus 2 will be 2, 2 plus 2 will be 4, and 4 plus 2 will be 6. And if it is inverse, 0 will go to 0 will be okay, negative 2, 2 will be 0, 4 will map to 2, and 6 will map to 4. Okay, now it seems like this is one-to-one, right? Hx, and the inverse also one-to-one, right? So now g negative 1 and h negative 1 function. That means the inverse are function. So the inverse, this is inverse, right? This is inverse. G negative 1 is not. It is not a function. So let's write down. G negative 1 Okay, let's write down properly. G, inverse of G is not a function. You know why? Because they are objects that have two images, more than one image, right? Two images. Alright, so inverse of G is not a function. How about inverse of H? Inverse of H is a function, right? So let's write down inverse of H is a function. Alright, why? Because each object has only one image. Right, so it's one-to-one. The inverse is one-to-one relation. Okay, so then we actually understand whether the inverse is a function or not a function. So the type of function that can have an inverse, okay, is a one-to-one function. Alright, the type of functions that can have an inverse is a one-to-one function. So the answer for number 3. What type of function will yield an inverse function? And state the conjecture. So you must know how to answer this. So let's write down the answer. What type? The type of functions that have an inverse is a one-to-one function. It must be one-to-one function. Okay, so that's how you answer. State the conjecture. This is a conjecture. The type of function that have an inverse is a one-to-one function. So, okay, that is how we answer the inquiry. Okay, we have to state the conjecture, means a sentence to support the activity. Alright, okay, so now from the result of inquiry 4, okay, we found that the inverse function is a reversal of a function such that every element in the codomain is mapped to only one element in the domain, right? Thus, we can conclude that a function f that maps set x to set y has an inverse function f negative 1 if f is one-to-one function. Okay, alright, so this is a very important concept. Okay, a function f that maps set x to set y has an inverse function f negative 1 if the function is a one-to-one function. Okay, please remember the concept. Remember this is very important fact. Okay,